Welcome to Pomodoro Joe for Wednesday, May 10th, 2023. Today we're doing LeetCode problem 59, Spiral Matrix 2. This is a medium problem. Given a positive integer n, generate an n by n matrix filled with elements from 1 to n squared in spiral order. So spiral order means you start out in the top left, which is 0, 0. You move to the right, then you move down, left, up, right, down, left, up, and repeat until you get to the center. All right, this is very similar to LeetCode 54, which is unspiraling a spiral matrix. So if you want, you can check out that video first. I'll try to leave a link somewhere. Otherwise, let's just jump into this one. All right, we'll put 25 minutes on the Pomodoro timer, and we will get started. So the first thing we'll need is our result, and our result is going to be a matrix. Well, that is an array of arrays, or a list of lists. So let's see, we'll have our result, and that's going to be, I'll fill it with zeros to start with, times n. That means we'll have at least one row that's of length n filled with zeros. And then I want n of those rows, so I'll say for every underscore, meaning we don't really care what this is, in range n. So this will give me an n by n matrix filled with zeros. Now you might be wondering why I did this one times n and this one underscore for range n. Well, this times n means that we're just going to multiply this 0 or duplicate this 0 for n elements in this list. That'll give me a list of length n of 0 element, or element 0 of length n. Now, if we were to do another multiply, like another times n, that would use the same copy of our initial row. So we'd have the same row basically being copied over and over and over again, but it's actually not even a copy. It's the same row itself. It's actually referencing the exact same row, which means that if we were to change, say, this element at index 0, it would change the entire column. Every row would have the same index 0'd value. So that's why we do this for underscore in range n. And that's a Python thing. Not every language will be like that, but that's just something to be aware of. At the end, we will return our result. Okay, so I'm going to treat this very similar to the way I did LeetCode problem 54. There's a couple things we'll need to keep track of. We're actually just going to go through and start putting elements at the right index. So we'll need to know what row and column we're at. So this is our current row and our current column. What else will we need to know? We'll need to know what our minimum row and our minimum column are, as well as our maximum row and our maximum column. So we'll start out with our minimums being 0 and 0. So our minimum row will be 0 and our minimum column will be 0. Now as we spiral, so we'll finish up this minimum row at row 0, then we'll go down. Now that we're done with this minimum row, we're done with row 0, our new minimum row actually becomes row 1. So we're going to eliminate row 0, we're done with it, and we'll move our minimum to row 1, and again we'll do the same thing when we reach our columns. We'll reduce our maximum column by 1, our maximum row by 1, our minimum column will increase by 1. We'll keep squeezing in and in and in until we get to the center here. All right, so our min row, that's going to be 0, and our min column will also be 0. Now our max row, that's going to be n minus 1 because I want the index. So n minus 1, and max column will be n minus 1. Again, this is the index of the row and column. I'll also need to keep track of which direction we're moving. So there are a couple different ways we can do that. I think, actually, I'm going to skip this part and we will come back to it in a minute. What else do we need? We need to know when we reach the end. We know we're at the end when we've basically put all of the elements in place. How do we know when we put all the elements in place? So let's just keep track of the count. So our max count, so how many elements do we need to put in place? Well, that's n times n. And what's our current count? Well, that's going to be 0. All right, so we have our current row and column. It's going to start at 0, 0. We have our max row and max column, and we have our min row and min column. That's just going to be our boundaries here. And then we have how many elements that we've placed and how many elements do we need to place. So while our count is less than our max count, that means we still have elements to place. So I'm going to do this a little bit differently. I'm going to say, well, we need to go right first. So we'll go right, and then we'll go down. So we're going to go right, then we're going to go down, then we're going to go left, and we're going to go up. So right, down, left, and up. Okay, so these are the basic elements we need. So how do we go right? Well, we need to go for every, I'll just call it I, in range from our min, let's see, this is going to be columns. We're going right, so we're going to do our min column to our max column, but this is non-inclusive. This is exclusive, so we need to actually include this max column, so I'll say max column plus 1. So that means for every index in our range from the minimum column to the maximum column, including the maximum column itself. So this will be 0, 1, 2. That'll be our I. Well, then let's see our result at, this is the same row. So this is going to be our min row because we're at this minimum row to start with. And we are at column I. Well, the value for that will be our count. Ooh, but our count starts at 0. So I can either start our count at 1, or I can say count plus equals 1 before we add it to our result. I think I'll do that. So we'll go through. We're basically going to traverse this entire row. When we get to the end, we are now done with this row. This is the minimum row, and we're done with it. So our min row gets increased by 1. So we finish this top row here. Now our minimum row becomes row 1. And now it's going to be very similar for our down, left, and right. So for I in range, now down, this is going to be moving down rows. So this is row 1, sorry, this is row 0, row 1, row 2. So we're moving down rows. So we're going to go from the min row to the max row. And again, I need to add 1 because it's an index and we need to make it inclusive. So to the max row, now our count will increase, just as we did before. Now our result. Now this one's going to be, our row is index I, and our column will be, this is going down the right-hand side, so that is our current maximum column. And that is going to be equal to our count. And when we get to the end, we are now done with this maximum column. We've finished, so we can move our maximum column down. So our max column minus equals 1. Next, we go to the left. Okay, so for I in range, so now we're moving left. We're going from the maximum column to the minimum column. So this is going to be a little bit strange. We're going to do a reverse kind of range here. So we're going from the max column to the min column. Now we have to do -1 because we want it to be inclusive. So we actually have to go a step beyond the min column. And we need to go in steps of -1. So this is a little bit different. This range function will take the start, the end, and then the direction of the step, or how many elements you'll step. And we'll be stepping -1 elements each time. That means we're moving from right to left. And then it's very similar. Our count will be increased, and then our result. All right, let's see here. So this result, now our column is the thing that's changing. So our row here is the max row. We're down here at the bottom, moving left, so that's our maximum row. And our column will be index I, and that will be equal to our count. Now we're done with this row, so we're done with the maximum row. So our max row gets decreased by 1. We're shrinking it in toward the center. And then our very last one, up, for I in range. Forgot the in here. Again, this is another negative range. We're going from the maximum row to the minimum row. So let's see. This will be a max row to the min row but we need to go one step further. So min row -1. And again, we need to go at steps of -1 because we're going up. So this is a little bit strange. 0, 0 is going to be in the upper left corner here, and it's positive. It's getting greater as you move to the right, or it's getting greater as you're moving down. This is called screen space sometimes because that's often how graphics work on screens. 0, 0 will be in the upper left corner. Okay, and we'll just continue this by incrementing our count and setting our result. Let's see, we're changing our row here. So our row will be index I, and our column will be our min column because we're down here at the minimum side of our columns. That's going to equal count. And when we get to the very end, let's see, we are done with this minimum column now. So our min column gets incremented by 1. Okay, so I think that's it. We have some basic stuff here. In fact, we didn't use this row and column because we're doing everything using these ranges, so we can get rid of those. We still need our min and max for row and columns. We need to know our counts. We need to keep track of our counts as we go. We also need to initialize our result so that we can index into it. And let's see, we're going right, down, left, not down, down, right, down, left, up, right, down, left, up. And we'll just keep repeating that pattern until we reach the end. Okay, let's see how we do. I'm so nervous that I made typos here. Oh, it works. Well, let's give it a shot. And we pass. We don't do great. We only beat 14% for runtime and 15% for memory, so it's not the best algorithm, but it's not bad. It's pretty straightforward, it's easy to understand, it gets the job done. So, if you do pass, you can check these out up here. This is pretty cool. So you can go up here and check out, well, I'm down here in the sort of lower percentile range. Let's see how some of these other ones go. Oh, it looks like they're doing the same thing. Oh, but they are going through half the loop. That's kind of interesting. So they're basically able to cut this down by half. That's why they get a better score. I wonder how they do that. Well, I is less than the loop. Looks like they're doing the exact same thing that I was doing. Well, I'd have to study this one a little bit. I don't immediately see how they're cutting this down by half. You probably see it. Maybe you can check it out. Try to take our algorithm and turn it into this one, and you can double our runtime, or reduce our runtime by half. Okay, well, I think that's it for me. Check this one out. This is LeetCode problem, what is it? LeetCode problem 59, Spiral Matrix 2. And if you like this one, you should check out LeetCode problem 54. I'll try to leave a link somewhere in the description. And yeah, check them all out. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.